Question 15. An underground train accelerating uniformly passes 4 signals in a straight line, each 24 meters apart. Let's have a look here. 4 signals. So 3 gaps between them, 24, 24, and 24. Let's call them A, B, C, and D. It takes 2 seconds to go from the first to the second, so time equals 2. 1 second to go from the second to the third, time equals 1. How long will it take to go from the third to the fourth? We don't know this time here, and we're looking for 3 decimal places in this case. Okay, what do we have here between A and B? A to B. We have S is 24. We have T is 2. We don't know U. We don't know A. But as we've seen before in these questions, we can form 2 equations in U and A, and we'll be able to solve them using the equation S is equal to UT plus a half AT squared. So 24 is equal to 2U plus a half by A by T squared, which is 4. So 24 is equal to 2U plus 2A. So 12 is equal to U plus A. Let's look from A to C. We have time is equal to 3 seconds. The distance is 48. U is equal to U. A is equal to A. So we're going to have 48 is equal to UT, 3U plus a half by A by T squared, which is 9. So 48 is equal to 3U plus 4.5A. Okay, well if I multiply this one by 3, I can get rid of my u's, or minus 3, so minus 36 is equal to minus 3u minus 3a. Bringing this one across, we're going to get 48 is equal to 3u plus 4.5a. Solving for a, we're going to get 12 is equal to 1.5a. So a will be equal to 12 divided by 1.5. So a is equal to 8 and 4 is 12, so a is equal to 8, and if a is equal to 8, we can see from up here u would have to be 4, so u is equal to 4. I'll just write the units underneath, meters per second, and now we're asked to find the time. So we have from A to C, we have S is equal to 24 by 3, 72. We don't know the time, but now we have U and we have A, 8. So 72 is equal to UT, 40 plus a half A, which is 8 by T squared. So we're going to get 72 is equal to 4T plus 4T squared. So dividing by 4 and moving the 72 across, we're going to have a minus 18, so T squared plus T minus 18 is equal to 0. And this, you can see, doesn't factorize. When we have 1 in the middle, the numbers will have to be 1 away from each other, which we can't have 2 factors of 18 that are 1 away from each other. So you can see the clue in the question, 3 decimal places, is the quadratic formula. So just set your calculator up to get your 2 answers for T. The positive answer will be the only one that suffices, in this case 3.772 seconds. Question 16. A car can accelerate at 1 meter per second squared and decelerate at 2 meters per second squared. How long will it take to travel a distance of 300 meters from rest to rest? And there's 2 questions here, subject to a 16 meter per second speed limit and subject to no speed limit. Okay, so let's have a look here. We're restricted, so we can climb to 16, then we can continue uniformly, and then we can decelerate to rest. And we have A is equal to 1 and deceleration is equal to 2, and my distance S is equal to 300. And you should at this point be able to put some numbers onto this diagram. If we can accelerate at 1 meters per second up to 16, it's going to take 16 seconds. And if we can decelerate at 2 meters per second and we're at 16 up here, it's going to take us 8 seconds. So we can get the distance traveled in both of these, and then this one will be the difference between what we have traveled and 300. So I'll do number 1 and number 2. 1 is going to be a half of 16 by 16, half the base by the height. Number 2 is going to be half of 8 by 16, which is going to give me 8 16s, 80 and 48, 128. And this has to be half of it, so 64. So that's going to give me 128 plus 64 is 192. And 300 minus 192 leaves me with 108. So if I call this x by 16, the area of that rectangle is equal to 108. And that's going to give me 6 16s is 96, so it doesn't go in evenly. It's going to be 6 remainder 12, and 12 over 16 is 3/4, so that's going to be 6 3/4. So 6.75 seconds. So how long will it take is the question. So we're looking at 6.75 plus 8 and 16 plus 24, 30.75 seconds for part 1. So part 2, no speed limit. So let's have a look at that. No speed limit. We're going to climb, hit the brakes, and come down. So I have my velocity here, max velocity. We're accelerating all the way along here to my max velocity with an acceleration of 1. So whatever I get to, it's going to take me half the length of time with an acceleration or a deceleration of 2 to come down. So there's a ratio involved here. So the times here, we take T1 and T2, T1 and T2, and this is my overall time. T1 will be twice as long as T2. T1 is equal to twice T2. So if it takes T to go all the way along it, we're going to have T1 is going to be 2/3 of the time, and T2 is going to be 1/3 of the overall time. So if we can get a value for velocity in terms of time, V is equal to U plus AT. So we take this in number 1 here. The velocity in terms of time is equal to 0. My acceleration is 1, and the time taken is 2/3 t. So velocity therefore is equal to 2/3 of the overall time. And we can now sub that in. So that's my perpendicular here in this triangle. So the area of that triangle is equal to 300. So half the base, which is t, the overall time, by the perpendicular height, which is 2/3 t, equals 300. So that's going to give me, I can cancel my 2's, I'm going to get t squared over 3. And instead of writing t squared over 3 equals 300, 3 by 300 is 900. So t therefore in this case is 30. Question 18, cyclists A and B leave the same spot from rest and travel in opposite directions. Okay, we'll have A going this way and B going this way. So we'll call these distances S1 and S2, or SA and SB. Let's call them SA and SB. SA and SB. Cyclist A accelerates at 0.5. A is equal to 0.5. And over here, cyclist B is accelerating at 1. How far will they be apart after 10 seconds? Okay, how far? So we're dealing with distance. So the distance for A is equal to UT plus a half AT squared. They start from rest, so U is 0. So the distance for A is going to be a half. I'll write it as a fraction, 0.5, a half by T squared. And the distance for B over this side is going to be a half by 1 by T squared. So we have to add these distances together to get their distance apart after 10 seconds. So I have S of A when T is equal to 10, it's going to be a quarter by 10 squared, so a quarter of 100. A has travelled 25 meters. And for B, it's going to be a half by 10 squared. So the distance for B is going to be 50. So their distance apart is going to be 75 meters. 50 plus 25 is 75 meters. And after how long more will they be 108 meters apart? So 108 meters apart, put in my units. Well, that's just SA plus SB is equal to 108. So SA in terms of, we had t squared over 4 for SA, or a quarter t squared. SB was t squared over 2. And that's equal to 108. If I multiply by 4, I'm going to get t squared plus 2t squared is equal to 432. So 3t squared is 432. Does 3 divide into that? T squared is equal to 144. So you can see, in fact, here it does divide in evenly. T is equal to 12 seconds. And the question asks us, after how long more? Now, after how long more? So the first part was 10 seconds. So that after 12 minus 10 is equal to 2 more seconds. Question 18. The max acceleration of a body is 4 meters per second. And the max retardation or deceleration is 8 meters per second. The shortest time, so we're looking at two triangles in which the body can travel a distance of 1200 from rest to rest. Okay, let's have a look. We'll get everything in terms of V here. Up and down. So I have V. A equals 4. I'll leave it as A here instead of D. A is equal to 8. From rest to rest. So if we look at V is equal to U plus AT, the velocity in number 1 is equal to 0 plus 4t. So t is equal to the velocity over 4. And in number 2, you can see it's going to be v over 8, but v is equal to u plus at. Now, we can set it up as the final velocity is v, and the initial velocity, is final velocity is 0 and the initial velocity is v. Then we would have to put a in as a negative minus at. Or you can just do it the same way as the first one. So in this case, v is equal to at, regardless of which way you do it. T is equal to v over 8 because time can't be negative. So I have my times now, v over 4 and v over 8. So S is equal to 1200, which is equal to the area half the base, v over 4 plus v over 8, by the perpendicular height, which is also v, is 1200. So this works out to be a half. Well, I'll get rid of my half straight away. I'll just multiply by 2. So I'll get 2400 on the right. And I'm going to get 8v plus 4v over 32 times v, which is 12v by v. 12v squared over 32 is equal to 2400. So does this simplify for me? V squared is equal to 2400 by 32 over 12. So v squared is equal to, so I can divide the 12 into the 2400. And that will give me 200. Now you just use a calculator here. I'm just trying to solve it without a calculator. 2 32s are 64. So 6400. So v, in this case, has to be 80. 80 squared is 6400. And we're asked the shortest time. So the shortest time of the time is here. Time is equal to v over 4 plus v over 8. So time is going to be 80 over 4 plus 80 over 8, which is 20 plus 10, 30 seconds. That's that question complete. Question 19. A cyclist traveling at constant speed, so no A, of 12 meters per second passes a point P. So let's have a look here. Here's P. Cyclist is going in this direction and its velocity is 12 meters per second. 5 seconds later, so that's t minus 5. 5 seconds later is t minus 5. A car starts from rest. So starting from rest, its initial velocity is 0 with a uniform acceleration of 1. What is the greatest distance by which the cyclist is ever ahead of the car? Okay, well, the cyclist is going faster than the car up until the point at which the car starts to go more than 12. So that means that the greatest distance is when their velocities are equal, when V1 is equal to V2, because once the car starts going more than 12, the gap closes. So the gap is growing until the car's velocity is 12. So the velocity of the bike is 12, V1. V2 is equal to U plus AT. So V2 is going to be 0 plus 1 times, and the time it's 5 seconds later. So 12 would have to be equal to T minus 5. So for 17 seconds, the bike is going to travel and be gaining on the car. So the distance for the bike is just going to be UT because there's no acceleration. So 12 by 17, 170 and 34 is 204 meters. And the distance for the car when T equals 17, S is equal to UT, well 0, we'll start it from rest, plus a half A, which is 1 by 17 squared. Not 17 by T minus 5, so 12 squared, half A T squared, should be careful. So a half 144 is 72, so the car's distance is 72. So if this is the point at which the velocities are equal, that's 204. The car has traveled 72, so the difference between these is going to be 28 plus 104. So the difference is going to be 204 minus 72, which is 132 meters. So I'll finish this video here. In the next one, we look at question 20 to 24.